All right, I'm thrilled to be here today. My name is John Stern. I'm the leader of North American AI field support for AMD, and I'm joined here by Quentin Anthony, the Vice President of AI Engineering at Zyphra.
Hey, nice to be here.
Nice to be here as well. I'm thrilled to be here with you. One of the reasons I'm thrilled to be here with you is that AMD and Zyphra have had a long partnership and relationship for years now, and I'd like to hear your perspective on, for folks who aren't familiar with Zyphra or your products, what Zyphra does and how they bring value to the market.
So Zyphra is trying to be like an open source alternative to the AI software stack. So we're trying to pre-train our own models. We do reinforcement learning of them to make them useful to everyday people within enterprises especially. And then we infer them on our own hardware that's provided by AMD. And we do all of this in the open. So all the models that we produce are open source, and you can see exactly how we made them.
Very cool, very cool. That leads me naturally to ask you, of all the hardware manufacturers out there and all the chips available, why choose AMD? What was the motivation there?
We compared a lot of different hardware vendors, and we found that AMD's like MI300X at the time GPUs really fit the bill for what we needed, which was very sparse, large MOEs as what we wanted to scale to. So we found the HBM capacity especially and its bandwidth were really amenable to our workloads. So we stuck with that, and we built a really strong engineering team to pull out that from the hardware. And then just over time, we've scaled up, and there's been no issue so far.
When I talk with all our customers, performance is important to them, but even more important than performance is partnership. And so what I try to do, with my team and what we try to do at AMD is partner with organizations like yours. And so I'd like to know a little more about having that partnership, what it's enabled you to do that, may have been harder or impossible to do had Zyphra chose to go it alone, as some companies do.
So AMD is nice in that it has it's a really large company, there's a lot of resources, and they're there's no big company ego. So we're able to like directly get to whoever knows the answer to my problem. They're very hungry to sort of improve the ROCm ecosystem, which has been really nice. So I just get to talk to whoever directly made the thing that I'm trying to debug right now.
Very cool, very nice. And so, when you think about companies like Zyphra, there is venture funding or investment that pays for those initial models and things like that, but eventually there has to be a business value that keeps the operations going. Can you talk a little bit about that journey at Zyphra from a frontier model to, everyday production and business value?
I think a good example for this that really illustrates what I'm going to say is like, imagine if DeepSeek just released V3 out of nowhere and it was totally closed source. No one knew where it came from. No one knew what DeepSeek was. Getting trust for people to plug your models into enterprise is a big deal. And so instead, DeepSeek worked over time to make open source models. They just open source research that was not yet like monetizable. So we kind of are trying to emulate this pattern of just like humble open source research that lets people understand where we're going and where we came from. We're intending to scale up as far as we can to make frontier models on AMD that are totally open. And once we reach that point on like a large frontier model, then people will be able to like exactly smell how we got there and that they can trust the model.
Very cool.
We also just like, it's not entirely commercial. Like we just enjoy working on AI. We want to make advancements in the field. People want to share the cool stuff that they've been doing.
Yeah, one of the great things about my role at AMD is getting to meet people who are passionate about AI like yourself. So I'd like to dive into that a little bit. Can you talk about, the full stack AI development, from the hardware to the kernels to the models and what that's all like for Zyphra?
It's kind of a personnel problem. So like you have to have people who are really smart researchers who are able to think outside the box. But if you've ever seen research code, it's not production ready, right? So you also need to have production people that are really good at mapping these crazy ideas that sometimes work onto hardware today, onto software today, onto algorithms today, and getting those people to be in the same room and to talk to each other and to see each other's points of view is really the challenge that we have to surmount. And it's an ongoing challenge that we are facing, yeah.
A lot of excitement in AI models today, particularly in architectures and things like that. I'm wondering if you can talk to me what excites you most about diffusion architecture, mixture of experts, all the new approaches to AI models in today's day and age.
I think it ties really into disaggregated hardware. I think everything is moving disaggregated. We'll have different accelerators right now everyone's working towards pre-fill accelerators or pre-training accelerators that are really good at this bulk synchronous high compute sort of regimes, which all the model architectures have kind of fit in around. And diffusion is another way of like moving one of the regimes that are bandwidth bound, which is like decode during inference, into this like prefill focused regime. I think as hardware sort of bifurcates into these different regimes, model architectures will do the same. So we'll have more interesting blocks. Like, why do we have attention, right? And why does attention have like these different MLA and GQAs? You started out with RNNs, and they were very poorly parallelizable. They didn't map to this hardware very well. So instead we brought in attention, but like regular MHA, like vanilla attention is really flop heavy. So we've tried all these different varying ways to reduce the flops, but still map them to this parallel hardware. So I'm really actually excited. I think there's gonna be kind of an explosion of different types of hardwares and types of like model architecture blocks that map to those hardwares and different regimes within serving. Like the same model architecture will have, prefill and decode, and maybe there are other like regimes that we could find. So I think it'll also even hit like networking. So right now, networking is mostly around sort of bandwidth focused, both internode and intranode, like AMD Infinity Fabric within the node. Then across nodes, you have AMD like Pensando Polara cards, and those are all really bandwidth focused. So I think shuffling data around will have different like latency-based fabrics and bandwidth-based fabrics, and will also affect parallelism schemes. So like, I'm kind of excited for the Cambrian explosion we're about to hit here.
Me too. In closing, I was kind of curious if you could talk a little bit about the one thing you'd like folks watching this video for the first time to remember about the AMD Zyphra kind of better together partnership. Is there one kind of key takeaway for you? For me, I think it's the way we can just accelerate innovation through combining the engineering talent at AMD and the engineering talent at startups like yours. But what is it for you that you'd like people to remember about the AMD Better Together story?
I think I see hardware as a bunch of trade-offs, and every hardware has its own trade-offs, and saying there's some bad or good hardware is a really oversimplification. It's like saying there's a bad and good food. Instead, you should see hardware as a set of trade-offs in terms of its like just quantitative metrics. You should also see your organization, like what capacity do we need? What kind of talent do we have? Are people more focused on model architecture versus do I have the performance sort of talent to be able to pull out what is latent in the hardware, the performance in the hardware? What are the costs, and when can I get these GPUs? So I think mapping hardware to the appropriate workloads and to my organization is the way people should be seeing things. And I think there will be more and more regimes where people find AMD fitting to be the best hardware for the job. There's a lot of workloads out there that we're going to keep picking up, but I'm sure other people will find them more and more.
How does one go from a single AMD workstream to a production-grade training cluster?
So we worked in a joint effort with AMD, IBM, and Zyphra. We all worked together to build out one of these first pre-training clusters at scale with completely AMD. So AMD GPUs, AMD networking, all the network cards were Pensando Polara. How does one like actually train a model with this? So we designed a topology that was Rails optimized instead of Rails only. A lot of the prior clusters were for inference and focused on this. So we had to find out, how does one change the network topology? How does one deal with Pensando Polara, and how does like its pluggable optics at scale? A lot of like just very hardware focused optimization problems that need to be resolved if one wants to train frontier models that we're trying to push for. So we built that cluster together, and we pre-trained the 8B model that we'll be talking about at AMD Advancing AI, as well as the 74 billion parameter model. And then we're now currently scaling up to much larger models that we intend to push the frontier with.
So how do you see rack scale solutions helping Zyphra?
So we're moving towards this Cambrian explosion that I was mentioning of different model architectures, but today they're all still focused on GPUs and on throughput focused sort of hardware. And rack scale is really sort of the extreme limit of this regime, where we can really push extremely large models, extremely large and sparse mixture of experts on these GPUs. And serve also extremely long contexts, we find. So scaling context parallelism across nodes is always a bit of a challenge. So keeping context parallelism within a single node and serving customers contexts of 500,000 or 1 million tokens within their sequences for really challenging work cases or really long reasoning traces is what we intend to use these for.
So would like to ask you, for your perspective on, we've talked a lot about GPUs, and what we're seeing at AMD is actually the CPU becoming cool again with respect to inference and agentic AI. Are you seeing any of that at Zyphra, or how is that impacting your business?
Yeah, so since we mentioned full stack before, we're pushing towards creating RL, reinforcement learning environments that are really CPU heavy, and that's why everyone is jumping into the CPUs. So we want to train both our models and provide as a service for others to train their open source models in reinforcement learning environments. These sandboxes of like, how does one set up an IDE? How does one solve a kernel programming problem, that kind of thing. So we're intending to scale quite a bit on providing CPUs as a service to users.
Quentin, it was great to catch up with you today at Advancing AI. Zyphra and AMD have a long partnership. Love working with your team, and it's been great catching up with you, so thank you so much.
Likewise, let's do it.